Assalamu alaikum يعطيكم العافية شباب. Today we will talk about specific charge experiment. As we know, if we have a charge moving with velocity v inside a magnetic field, uniform magnetic field, this charge will experience a force called Lorentz force. Okay? Since we have cross product, so the force is equal QVB sine theta, where theta is the angle between V and B. Now, in today's experiment, we will assume the Q is the charge of electron and theta is equal to 90, which means the velocity is perpendicular to the magnetic field. For example, if we have the velocity direction to the right and we have magnetic field inside, the force will be up. Now, because the direction of motion, for example, if it is to the right and we have the force up, so this will cause a circular motion for the charged particle. Now, since we have a centripetal force, this force equal m is centripetal, and we know the acceleration in centripetal force equal to v squared over r. Now, we have from this equation the magnitude is E v b sine 90 is 1 should equal to m v squared over r. By arranging this equation, we will get E over m is equal to v over r v. This v actually is not easy to calculate it, but we can use the conservation of energy to eliminate this v. The kinetic energy is equal to mv squared. This will be equal to E multiplied by the potential difference. Now, by arranging this equation, we will get E over m is equal to v squared over 2v. Now, by combining these two equations, we will get the following equation. E over m is equal to 2v divided by r squared b squared. Now, in this equation, if we have a constant magnetic field B, and now we will explain how to calculate this B, and I start to change the voltage, we will change the radius of the circular motion, and we will detect this circle experimentally. Now, we will see how to calculate this B. To calculate B, we will have two circular coils. Each coil has n turns on each. This coil is called Helmholtz coils. Now, the field is uniform near the center. This is the advantage of these coils. Now, using this equation for the specific dimensions we have, B is equal some constant multiplied by mu naught n over r multiplied by I. So the relation between I and B is this relation. Here mu naught is the permeability, and it's equal to 4 by 10 to power minus 7 Tesla meter per ampere. N is equal 130 turns, and R is the radius of the coils, and it's equal to 15 centimeter. Now experimentally, we will change the voltage until we hit the 2R, specific 2Rs. For example, we will start with 5 centimeter. We will change the voltage until we reach 5 centimeter, then 6, 7, 8 until 10 centimeters. After that, we will find delta V. According to our write-up, delta V here is 5% of our V. Then your role to find R squared and the error in this R squared. Then, according to our equation, you will find E over m, where V is given from the table, R squared from the table, and B squared you have already calculated from this equation, where I will be 1.8 ampere and R 15 centimeter. Then you will find the error in E over M and record it here. Here is our equipment for today's experiment. As we see, we have two helmets coils. Each one has a radius of 15 centimeter. And here we have a cathode ray tube. This one is to provide electrons by applying the voltage difference or potential difference. Inside the tube we have the phosphor coated crossbar. Here, once the electrons or helium ions hit this rod, it will be illuminated. This tube is filled with helium gas at low pressure. If electrons of sufficient kinetic energy collide with the helium atoms, there will be a fraction of atoms ionized. Ions with stray electrons will be observed as a green spectra. Here we can read the voltage, and here we can read either voltage or the current, but we put the switch to be current. Now I will fix the current to be 1.8 amperes, and I will start tune the voltage until here inside to hit the 2R that we will the needed 2 R's. Here if you see inside the bulb there is a green circle. I will change the voltage and see that this green circle change in radius. Now I will start with first 5 centimeter. I will search for the 5 centimeters to hit it. This is 6 and this is the 5. Now here if you see the circle and the 2R of this circle is 5 centimeter. Here we need to record the voltage. At 2R equal 5 centimeter we have 143 volts. Now I will increase the voltage to hit 6 centimeters. Now 2R is equal to 6 centimeters, and the voltage that we have, it's about 197 volts. I will do all the steps until we reach about 10 centimeters. Now the rest of the data will be provided in the table. As we saw that we changed the voltage to find 2R, and the rest of the data will be provided for you in the Word file. At the end, it's your job to find delta V from the voltage we recorded or provided, and you will find delta of R squared. Then you will find the delta of E over M. Now, after that, you will find the average of E over M plus minus the delta of E over M.